Welcome back. This is section 5.4, more trigonometric graphs. So what we're going to look at in this section are the other four trigonometric functions and what their graphs look like. So remember in 5.3, we looked at sine and cosine. In this section, we're going to look at tangent, cotangent, and then cosecant and secant. So the first thing we need to understand are the periodic properties of those functions. So if you remember with sine and cosine, the period of those two functions was 2 pi. Well, the period of tangent and cotangent is actually only going to be pi. And so whenever we're doing the periods here, we just have to remember that we're only graphing one complete period of pi. And then when we adjust that period, we're going to take pi divided by k instead of 2 pi divided by k like we did with the first two functions. Now, cosecant and secant, because they're reciprocals of sine and cosine, are going to have the same period as sine and cosine. Okay, so both of those functions have a period of 2 pi, and so those periods will behave the same way that sine and cosine did. Now, here are our basic graphs of the tangent and the cotangent function. So our first one here on the left, this is going to be our tangent function. Now, the key things that we need to recognize so that we can actually graph these are where are the vertical asymptotes and where does it cross the x-axis? Where is that intercept? Okay, so for tangent, notice here we've got an asymptote at negative pi over 2. We've got an asymptote at positive pi over 2, and our x-intercept is at 0. Also notice that it's increasing from left to right, and so we're approaching negative infinity on the left, positive infinity on the right. Okay, and so that's going to be the graph of our tangent function. So again, if you just recognize where are the asymptotes, where does it cross the x-axis, and is it increasing or decreasing, those are the key things you need to know to be able to sketch these graphs. Okay, now our cotangent function, which is the one on the right, has a vertical asymptote at 0 along the y-axis, another vertical asymptote at pi, and its x-intercept is actually at pi over 2, and it decreases from left to right. So notice on the left, we're approaching positive infinity. On the right, we're approaching negative infinity. And we pass through pi over 2 right in the middle. Now, again, these are just one complete period of these graphs. And so they are periodic. They're going to continue forever and ever. And so you can continue to repeat this pattern out towards positive infinity and negative infinity if you wanted to. But again, for testing purposes, I'm only ever going to ask you to graph one complete period. And so as long as you know where those asymptotes, the x-intercept, and whether it's increasing or decreasing, that's all you really need to worry about in terms of sketching these graphs. Now, our cosecant and secant graphs. Okay, so this first one here, this is going to be our cosecant. Remember, cosecant is the reciprocal of sine. And so they actually sketch the graph of your sine function in blue here. The red itself is the cosecant graph. Okay, so just understand that when you're graphing these, we don't graph the blue part. We're only graphing the red part. Okay, but they're just showing you the relationship now between sine and cosecant. Again, with cosecant, we're going to have vertical asymptotes. In this case, the vertical asymptotes are going to be at 0 along the y-axis, at pi, and at 2 pi. And again, the period of cosecant should be 2 pi. So if we graph from 0 to 2 pi, we've graphed one complete period. Notice on the y-axis, we have this value at positive 1. And down here, we would also have a value of negative 1. And so our highest and lowest points for those U-shapes between the asymptotes are going to be at positive 1 and negative 1 for our parent function. Now, with the secant graph, because that's the reciprocal of cosine, we're actually going to get asymptotes at pi over 2 and 3 pi over 2. And when we graph this now, you can see that our u is kind of split. So we have part of the u from 0 to pi over 2. The other part of that u is at 3 pi over 2 to 2 pi. And then the one that's upside down is between our two asymptotes at pi over 2 and 3 pi over 2. Now, if you wanted to, instead of graphing from 0 to 2 pi, you could graph from like negative pi over 2 to 3 pi over 2, or you could graph from pi over 2 to 5 pi over 2. Right, extend that domain a little bit. And that way you would get a complete u on either side. So if you wanted to, again, you could extend this and you'd get that complete u. Or you could extend it this way and you'd get that one. But again, you'd have asymptotes here and here if you were to do that. Okay. So it's really up to you if you want to graph from 0 to 2 pi, or if you want to graph from negative pi over 2 to 3 pi over 2, or from pi over 2 to 5 pi over 2. And again, these patterns repeat over and over and over again, so it really doesn't matter where you start and stop, as long as you've got one complete period in there, which would be 2 pi. All right, now this is again is just showing you that these are periodic. So here's our tangent function, more than one period, right? So we said one complete period would be from negative pi over 2 to pi over 2. They're just showing you that we can extend that, and you see all these asymptotes with that pattern repeating. Same thing with cotangent. If we were to extend that, you would see all of the asymptotes with that pattern repeating. All right, so let's see if we can sketch a graph for each one of these. And again, we're just going to worry about one complete period of each function. So the first thing we need to recognize is what is the parent function. So our parent function for tangent, let's sketch that out. Remember, we're going to have vertical asymptotes at negative pi over 2 and positive pi over 2. We're going to have an x-intercept at 0, and it's going to be increasing from left to right. Okay, so this is our tangent function, tangent of x. Now, in this case, because we're graphing 2 tangent of x, the only thing that's going to change here is that we're going to stretch this graph vertically. Okay, so sketch this one out. If I stretch my graph vertically now, the asymptotes actually don't move, right? I'm not doing a shift left or right. I'm not adjusting the period here. And so I'm still going to have a vertical asymptote at negative pi over 2. I'm going to have a vertical asymptote, positive pi over 2. Again, extending this vertically is not going to change where it crosses the x-axis. Okay, so we're still going to have our point at 0, 0. But we need to make sure that we're elongating this vertically when we do this. So it's just going to be stretched out. And we get something like this. Okay, so same vertical asymptote, same x-intercept. We're just stretching vertically so it looks a little bit more elongated. That's all. All right, now our next one, negative tangent of x, we're going to have the same parent function, tangent of x, but now remember the negative in front of our function gives us a reflection over the x-axis. So if we sketch this, reflecting over the x-axis is not going to move those asymptotes, so I'm going to keep those in the same place. So we have negative pi over 2, positive pi over 2. Reflecting over the x is also not going to change our x-intercept. That's still going to be at 0, 0. But now everything that would have been down in the third quadrant gets reflected up into the second quadrant. And everything from that first quadrant gets reflected down into the fourth quadrant. So our reflection, negative tangent of x, should look something like this now. So again, no shifts yet, and also no changing of the period. And so in this case, we're just looking at either stretching because of the 2 out front, or if we have a negative in the front, just remember that's going to reflect over the x-axis. All right, now, if we have something with a k value on the inside, remember, just like with sine and cosine, that's going to affect the period of your function. Because the period of tangent and cotangent is originally pi, though, when we do this, we're actually going to take pi divided by k instead of 2 pi divided by k. So just remember, with tangent and cotangent, it's always pi divided by whatever the k value is. That's going to give you the new period for your graph. All right, so let's take a look here. So this time we've got tangent of 2x. So notice the 2 is inside. We have a k value this time. So the first thing we're going to want to do is actually figure out what is the new period of this graph. So remember, for tangent, we're going to take pi. We're going to divide it by the k value. And so our new period is going to be pi over 2. Now I'm going to sketch the parent function over here again, just to remind ourselves where our asymptotes are. So we had negative pi over 2, positive pi over 2, point at 0, 0, increasing from left to right. All right, now this time, because the period's only going to be pi over 2 instead of pi, so think from negative pi over 2 to pi over 2, that distance is pi, right? That's why we've got one complete period there. We need to shrink that to pi over 2 instead, which means that our asymptotes are going to have to move to account for that. Basically, what's happening is we're cutting those asymptotes in half so that we cut our period in half. So to do that, I'm actually going to take negative pi over 2, and I'm going to divide it by that k value. I'm going to divide it in half. Well, remember, when we're dividing and we're dealing with fractions, we can multiply by the reciprocal. So I'm going to think of that 2 as 2 over 1. I'm going to get negative pi over 2 times 1 over 2. And negative pi over 2 times 1/2 should give us negative pi over 4. So now that tells me on my new graph for tangent of 2x, my first asymptote is going to be at negative pi over 4. Now we can do the same thing with the other asymptote. So we have pi over 2 divided by 2. Again, that's going to be pi over 2 times 1/2. And so we get positive pi over 4. So now I know where my two asymptotes are going to be. Now we just need to figure out where the x-intercept is going to be. Well, in this case, our x-intercept is at 0. Again, I'm going to cut that in half, just like I did with my asymptotes. But 0 divided by 2 is still 0, and so my x-intercept does not move this time. Now, beyond that, we don't have any shifts, we don't have any reflections, and so my graph should look very similar to the original graph, increasing from left to right between those two asymptotes, and so we get something that looks like that. Okay, and notice here the distance between negative pi over 4 and pi over 4 is pi over 2, and so we've adjusted our period now to pi over 2 instead. All right, now the next one is going to be very similar in terms of period, right? Because we still have the same k value of 2, so we don't really need to find the period. It should be pi over 2, just like the previous one. But this time we have a shift because of the minus inside. So remember, this is going to shift, and the minus goes to the right, pi over 4. Okay, so these shifts are going to be exactly like our sine and cosine. Subtraction moves it to the right, addition is going to move it to the left. So now what I want to do is I want to take that graph that we got in the first part, right, with our adjusted period from negative pi over 4 to pi over 4, and I want to shift that to the right by pi over 4. Okay, since I've already adjusted the period in the first part, now I just need to shift that graph. Well, if I shift everything to the right pi over 4, I'm going to move the asymptotes and I'm going to move the x-intercept. So what I'm going to do is I'm going to say, well, let's take the first asymptote, negative pi over 4. I'm going to add pi over 4 so that it moves it to the right that many units. Well, negative pi over 4 plus pi over 4 should just be 0. So that tells me for this graph, first asymptote should be at 0. And now I'm going to go ahead and find my other asymptotes. I'm going to take pi over 4. I'm going to add pi over 4 to shift that one to the right. This gives us 2 pi over 4, but that simplifies to pi over 2. And so now my other asymptote should be at pi over 2. And then finally, we just need to adjust our x-intercept. It was at 0. We're shifting it to the right pi over 4. And so that new x-intercept should be at pi over 4. Again, no reflections, and so this should still be increasing from left to right. And so we have our two asymptotes, we have our x-intercept, and we're just going to make sure we're increasing through that x-intercept from left to right. So again, just in general, always start with your parent function. Make sure you know where those asymptotes are. Where's the x-intercept? Is it increasing or decreasing? Then from there, if we have a period change, we just need to adjust those asymptotes and x-intercepts accordingly. And if there's a shift, then we can just move it left or right based off of that after we've adjusted the period. All right, so now we're looking at a cotangent graph. Well, first thing I'm going to do, I'm going to go ahead and sketch our parent function just so we remember what that looks like. So for cotangent, remember our first asymptote was at 0. Our other asymptote is at pi. X-intercept, pi over 2. And remember, cotangent decreases from left to right. So we're going to get something like this. So there's our parent function. This is our cotangent of x. Now, with the function that's given, remember, if there's ever anything inside the parentheses being multiplied by the x, the first thing we have to do is factor that out. So I'm going to rewrite this now as y equals 2 cotangent of 3 times, and then we're going to have x minus, and we need to figure out what that pi over 4 is going to become if we factor out a 3. So we're basically dividing pi over 4 by 3. So we have pi over 4 divided by 3. Remember, we can think of that as 3 over 1. So that's pi over 4 times 1 over 3. And so we actually get pi over 12 now. Okay, so all of this now is inside that cotangent function. But again, anytime there's a number in front of your x, make sure you factor it out because that is going to change what it looks like the shift should be, right? So first thing we need to do, let's identify our period and any shift that we have, because then we should be able to sketch our graph from there. So period this time. Remember, with cotangent, we're taking pi divided by the k value. So this time it's going to be pi divided by 3. And then our shift, once we've done our factoring, it's going to go to the right, pi over 12. Now, the way I'm going to do this is I'm going to do 2 separate graphs. I'm going to start by just drawing a graph that changes the period. Then I'm going to draw my second graph, which will be our final answer, where it actually does the shift. Okay, so I'm just going to think about the period first, then I'm going to do the shift. Well, if we want to think about doing a period of pi over 3, remember, we can take each one of our asymptotes and the x-intercept, and we can just divide by that k value. So I'm going to start with my 0. That's my first one. So we're going to do 0 divided by 3. So my first asymptote is still going to be at 0 for this graph. Okay, so again, this is not my final answer. This is going to lead us to that final graph. Okay, so I'm still going to have one at 0 here. Now I'm going to look at my other asymptote. It was at pi. I'm dividing that by 3. So that's just going to be pi over 3. So pi over 3 should be my other asymptote. Then I'm taking the x-intercept, pi over 2, dividing that by 3. So that's pi over 2 times 1/3, which gives us pi over 6. So So that's our halfway point there. Again, it's decreasing from left to right. So this is cotangent of 3x. So again, that's only dealing with the period itself, right? We haven't done anything with our shift yet. But now that we've changed the period, now we can just shift based off of these new values that we've got on this graph. Okay, so now I'm going to do my final answer. I'm going to shift those values over. So I'm going to start with my 0. That's my first asymptote. I know I'm shifting to the right, pi over 12. So I'm going to add pi over 12. And so my first asymptote should be at positive pi over 12. I'm going to go ahead and do my other asymptote. So we'll do pi over 3 plus pi over 12. Now I need a common denominator this time, so that's going to be 4 pi over 12 plus pi over 12, which should give us 5 pi over 12. So my other asymptote out here, 5 pi over 12. And then finally, we need to move the x-intercept over. So I'm going to do pi over 6 plus pi over 12. Again, we need a common denominator. That's 2 pi over 12 plus pi over 12, which is 3 pi over 12. But 3 pi over 12 simplifies to pi over 4. So this x-intercept here should be pi over 4. Now, once we have all of that information, we know it's decreasing from left to right. And there we go. And so that right there is our final answer. This is, oh, and I didn't really deal with the 2. Remember, the 2 out front is going to stretch this vertically. Okay, so try to make sure that it's elongated a little bit. Just know that on a test, I'm not going to be super picky about that because it's difficult without any y values to determine if you actually did the stretch. Again, the main things I'm looking for are, can you get the asymptotes in the right place? Can you get that x-intercept in the right place? And is it increasing or decreasing, right? Those are the things I'm looking for with tangent and cotangent. Okay, so this right here should be 2 cotangent 3 times x minus pi over 12. And again, if you need to draw that middle graph there, right, where you just adjust the period first and then do your shift, that's perfectly fine. If you feel comfortable doing all the steps in one, that's perfectly fine as well. All right, so now let's look at our cosecant and secant graphs. So remember, the original period of cosecant and secant is 2 pi. So if we're adjusting the period now, it's going to be 2 pi divided by that k value, just like sine and cosine were. Okay, so let's see if we can sketch these graphs. So again, first thing we need to do is think about our parent function. So I'm going to sketch the graph of cosecant. Now remember, our cosecant graph, we had an asymptote at 0. We had another asymptote at pi. And then finally, we had an asymptote at 2 pi. Now, along the y-axis, this time we do need some values. Our values are at 1 and negative 1. Now, between our first two asymptotes at 0 and pi, we have a u that opens upward. So we're going to get something like this. And then the one that's between pi and 2 pi, that one's opening down. So again, those are the key pieces of that graph that you need to recognize, right? What are the y values along the y-axis? Are those u's opening up or down? And then where are those asymptotes? Now, for this particular graph, we've got a 1/2 cosecant of 2x. So we know the period's going to change. So that's the first thing I'm going to look at. So let's take the period here. We know it's 2 pi divided by the k value, which is 2. And so the new period should be pi instead. So let's see if we can sketch this. Now, just like before, basically what I'm going to do is I'm going to take all of my asymptotes and I'm going to say, well, I'm dividing by 2, so that's going to cut all the asymptotes in half so that my period becomes pi instead. So I'm going to do 0 divided by 2, which is 0. So my first asymptote does not move, still at 0. My next one was at pi, cutting that in half. So it's going to be at pi over 2 now. And then my last asymptote was at 2 pi. Divide that by 2. So that one should be at pi. Okay. Now, the other thing we have to look at this time is we do have this 1/2 out front. Remember what that's going to do is it's actually going to shrink it vertically. That's also going to change these y values along our y-axis. So instead of being 1 and -1, they're going to be 1/2 and -1/2. Just always pay attention. If there's an a value being multiplied by your function out front, we always have to adjust those y values for cosecant and secant. Now, beyond that, there's no reflections, no shifts, and so our u's are going to look exactly like they did before. First one's opening upward. And then between pi over 2 and pi, that one goes down. All right, now this bottom equation, notice here the 1/2 is exactly the same. We have the 2, that's our k value again, and this time we're going to have a shift. So we're basically going to be able to use what we found in the first part to help us figure out what this graph looks like. Now remember, always factor out if you have something being multiplied by the x. So this is going to give us y equals 1/2 cosecant 2 times x plus, and if I factor out a 2 from pi over 2, should give us pi over 4, right? And again, that's just pi over 2 divided by 2. That gives us pi over 2 times 1/2. And that's where we get that pi over 4. And so that tells us now that we're going to have a shift. This time our shift is to the left because it's addition. And it's left pi over 4. All right, so we already know the period is going to be pi, just like the previous one because of the 2. We also know our values along the y-axis are going to be 1/2 and -1/2. So now we just need to figure out where are those new asymptotes going to be. Well, I'm going to take the asymptotes from our top graph and I'm going to shift them to the left by pi over 4. So I'm taking my 0, I'm going to move it left pi over 4, so I'm subtracting. So my first one's going to be at -pi over 4. So we're going to have an asymptote over here, -pi over 4. My next one was at pi over 2. Shifting it to the left pi over 4. I need a common denominator. So So that's 2 pi over 4 minus pi over 4. And that should give us positive pi over 4. So we have another asymptote here, positive pi over 4. And then finally, we had one at pi. Shifting that to the left, pi over 4. Common denominator, 4 pi over 4 minus pi over 4. And that gives us 3 pi over 4. Now again, in terms of our u's themselves, they're still opening up between the first two asymptotes, down between the second two asymptotes because we don't have any reflections here. And so our first one should look like this. And then our other one opening down like this. Again, always start with your parent function for cosecant and secant. Just make sure you know where are the asymptotes, what are those values along the y-axis, and then are the u's opening up or down between each of your asymptotes. From there, we can adjust the period, and then if you have a shift, once you've adjusted the period, then we just adjust those asymptotes based off of that shift. All right, so example 5 says when a graph 3 secant of 1/2 x. All right, so we are dealing with secant this time. So the first thing I'm going to do is think about my parent function. I'm going to graph secant x. Now remember, secant is actually going to have our first asymptote, pi over 2. Next asymptote, 3 pi over 2. And our last point out here is at 2 pi. We still have values at 1, -1 along the y-axis. And so what happens is our u gets split up, right? So we have half of our u right here. The one that opens downward is between the pi over 2 and 3 pi over 2. And then the other half of our u is between 3 pi over 2 and 2 pi. So that's one complete period between 0 and 2 pi now. All right, so first thing I want to do, I notice here I have a k value, so let's find the new period. So we're going to take 2 pi divided by 1/2. That's the same thing as 2 pi times 2 over 1. And 2 pi times 2 is 4 pi. So basically our period increased from 2 pi to 4 pi. So next thing I'm going to do, let's figure out where those new asymptotes are going to be. So I'm going to take pi over 2 divided by 1/2. It's pi over 2 times 2 over 1. In this case, my 2's cancel out and just give us pi over 1 or pi. So when I sketch my graph, first asymptote should be at pi. And I'm going to do the same thing with 3 pi over 2. Dividing that by 1/2. Again, my 2's cancel out, and we get 3 pi. And I know my complete period is 4 pi, so my graph's going to end out here at 4 pi. Now, the other thing we have to pay attention to is we do have an A value this time. So we have this 3 out front. Remember, that's going to change what those Y values are. And so I just need to make sure that my graph is at 3 and -3 along the Y-axis now. Now, other than that, no reflections. So our graph should have that same basic shape as the original. So we're going to start along the Y-axis. Our first U is going to open upward towards that first asymptote. And we have this point between pi and 3 pi. This U is going to open downward. And then finally, the other half of our U coming down like this. And there's our one complete period from 0 to 4 pi now. So again, to reiterate, the key with these graphs is knowing the parent functions really well. Make sure you know where all the asymptotes are. Make sure you know for tangent and cotangent where those x-intercepts are. For cosecant and secant, make sure you know whether the u's are opening up or down, and make sure you know what those y values need to be along the y-axis. Okay, so make sure you've got the parent functions, because from there, it's just adjusting asymptotes and x-intercepts and things like that based off of any changes in the period and then any shifts that you might have. So as always, if you have any questions as you're working through this homework, please let me know. Come see me during student hours if you need to. Have a great week, and I will see you next time.